gears are round wheels with teeth. When one gear turns, it pushes the teeth of another gear, and that gear also turns. Gears are used to move power from one part of a machine to another. We use gears to change speed, change direction, or increase turning strength. A motor usually spins very fast but does not have much strength. Gears help convert that fast motion into slower and stronger motion. This is why gears are used in fans, vehicles, machines, and tools. Torque means turning strength. It tells us how strong the turning force is. Imagine opening a tight bottle cap. Using your fingers is hard, but using a long tool makes it easier. That extra help is torque. In machines, high torque means strong turning power, and low torque means weak turning power. Motors give speed, but gears help increase torque when more strength is needed. Gear ratio explains how speed and torque change between gears. When a small gear turns a big gear, the big gear turns slowly, but with more strength. When a big gear turns a small gear, the small gear turns faster, but with less strength. Gears always trade speed for torque or torque for speed. You cannot get both at the same time. A simple gear train uses one gear to directly drive another gear. In this setup, power comes from the battery and motor, which turns the first gear. That gear turns the next gear, which moves the fan. If both gears are similar in size, the speed change is small. If the second gear is bigger, the fan turns slower, but with more power. Simple gear trains are easy to understand and are used when only one speed change is needed. In designing these gears, engineers must consider the size and shape of each gear to maximize efficiency. This requires careful calculations and adjustments to ensure that the energy transferred from the motor effectively powers the intended mechanism. The interplay between speed and torque is crucial. Understanding this principle allows for the creation of machinery that performs optimally under different conditions. With the right setup, a simple gear train can be transformed into complex systems that enhance productivity and performance across various industries. When two gears touch each other, they rotate in opposite directions. If the first gear turns one way, the second gear turns the other way. This is useful when a machine needs motion in a specific direction. Adding more gears can change the direction again without changing the motor. A compound gear train uses more than two gears. In this setup, two gears are fixed on the same shaft and turned together. One gear drives the next, and that gear drives another one. This allows a large reduction in speed and a big increase in torque. That is why compound gear systems are used in machines that need strong power at low speed, like cranes and gearboxes. As speed goes down, torque goes up. Energy is not lost, it is just changed. In a compound gear system, each stage reduces speed and increases strength. By the time motion reaches the final gear, it turns